find the distance between the parallel lines. If you will see everyone, parallel lines on the xy plane. So let's say this is one line, this is second line, and they both are parallel. So actually we have the direct formula for the distance, right? Now the parallel lines you have learned in class 10th, the parallel lines is something like y is equals to mx plus c1, and second equation we have y is equals to mx plus c2. The difference, if you will see, is only of C1 and C2, because the ratio of the parallel lines said that A1 by A2 is equals to B1 by B2 is not equals to C1 by C2. That you have already learned in class 10th, okay, when you are learning about the lines ratio. So it's very easy. Now we direct have the distance formula. A1, A2, B1, B2, they both have, all the ratios are same only. So now what we will do, we will apply the direct formula for the distance, which is equals to modulus of C1 minus C2 over A square plus B square. This is a direct formula. A and B, they both are same in both, because here the coefficient of y is 1. Here it is m. Here it is 1. Here it is also m. So A and B you can take out from any of the equation. Right, C1, C2 you have to work out. Now this is the first question. If you will see, the coefficient of x is 15 here also, and it is 15. Here it is 8. Here it is 8. Now C1 is negative 34 and C2 is 31. So when I put it for the first question, for the first part, when I put it in the formula, so C1 is negative 34 minus C2, which is 31, square root of A square, which is 15 square, that is 225, plus B square, that is 8 square, which is 64. So that is equals to modulus, because the distance is always positive. So it will become negative of 65 over, wait a minute. So 65, and the value is root 289, which is 17 square. So 17 it will be. Now we know that distance is always positive. So we come out the distance out of the modulus, and we got a positive value, which is 65 over 17. Now when we will do same thing for the second part, same formula I will apply, but here if you will see, the L is outside the bracket. So when I open the bracket, it was Lx plus Ly plus P is equals to 0. So A and B, they both are same. Again, they are the parallel lines. So we just have to put the formula. C1, which is P, minus C2, which is negative R, over L square plus L square, because A and B, they both are same, LL, right? So it will become P plus R over L square plus L square is 2L square. When I put it outside the square root, L square will come out as L, and it's 2 root 2 only. So D is equals to P plus R over R, L root 2. This is L, sorry. Okay, this is L root 2. Okay, this is L. Right? So this is the final value. Yeah, thank you. Thank you so much.